Elastic collision in one dimension. See, head-on collision. We are going to find the velocity. After collision, what will be the velocity? See, we have taken elastic collision. In elastic collision, what are happening? Total linear momentum is conserved, and kinetic energy before collision is equal to kinetic energy after collision. See here, I have considered two particles A and B, mass m1 and m2 moving along a straight line, speed u1 and u2. u1 is greater than u2, hence they will collide. m1 will collide with m2. Here they have collided and transferred their energy and momentum. What happened? After collision, velocity of particle A is v1 and velocity of particle B is v2. So consider two particles A and B having mass m1 m2 moving along a straight line, speed u1 u2, collide head on. After collision, speed of A becomes v1 and speed of B becomes v2. So see, what do we know? In elastic collision, first thing, there is conservation of momentum. So by law of conservation of momentum, momentum before collision is equal to momentum after collision. So what will be the momentum before collision? Mass m1, speed u1, so its momentum is m1 u1. Here momentum, its second B particle has momentum m2 u2. So what will be the momentum before collision? So that is m1 u1 plus m2 u2. After collision, momentum becomes m1 v1 plus m2 v2. So see, these are the momentum before collision and after collision. m1 u1 plus m2 u2, m1 v1 plus m2 u2. So this comes by law of conservation of momentum. See, if m1 v1 I have taken left hand side, m1 mass, m1 u1 minus m1 v1, this I have taken right hand side, m2 v2 minus m2 u2, m1 I have taken common to u1 minus v1, here m2 I have taken common to v2 minus u2. So this I have given first equation. First equation, m1 u1 minus v1 is equal to m2 v2 minus u2. See, in elastic collision, what I have told you, kinetic energy is also conserved. So kinetic energy is conserved. So initial kinetic energy before collision is equal to final kinetic energy after collision. So initial kinetic energy will be what? Half m1 u1 square plus half m2 u2 square before collision. After collision, half m1 v1 square plus half m2 v2 square. In the same thing, we will take this left hand side, half m1 u1 square minus half m1 v1 square. This I have taken right hand side, half m2 v2 square minus half m2 u2 square. Half m1 I have taken common, this becomes u1 square minus v1 square. Here half m2 I have taken common, v2 square minus u2 square. Half cancel, a square minus b square. A square minus b square, what we know? A minus b, a plus b, same thing we are applying here. So u1 minus v1 and u1 plus v1. Here a square minus b square, to v2 minus u2, a minus b and a plus b. Suppose this is the second equation. This is first, this is second equation. If divide equation 2 by equation 1, divide equation 2 by equation 1, what happened? See, m u1 minus v1, here m1 u1 minus v1, so this will be the cancel out. when we are dividing 2 by 1, ये 2 इक्वेशन को 1 से डिवाइड करेंगे, अपान में आएगा तो दे विल कैंसिल आउट, m1 कैंसिल, u1 माइनस v1 कैंसिल, तो व्हाट इज द रिमेनिंग ओनली, तो u1 प्लस v1 इज इक्वल टू this also m2 v2 minus u2 cancel out, v2 plus u2. If u2 I have taken here, the u1 minus u2 is equal to what, v2 minus v1. See, one result we have found it, u1 minus u2 mean relative velocity of approaching, relative speed of approaching is equal to what, v2 minus v1, that is what, relative velocity of separation. So one result we have found it, relative speed of approaching, relative speed of approaching is equal to relative speed of separation, speed of separation. So here you can see also, if they are equal, so what is coefficient of restitution, that is v2 minus v1 upon u2 minus u1 minus u2, both are same, so this will come E is equal to 1. One thing we have seen, in head-on collision, elastic collision, their momentum is conserved, kinetic energy is conserved, momentum is conserved, here I have taken, kinetic energy is conserved, here I have taken, and we have divided equation 2 by 1. One important thing we have shown, that relative velocity or relative speed of approaching is equal to relative velocity of separation. तो इलास्टिक कोलिजन में क्या होगा बेटा, जिस रिलेटिव वेलोसिटी से वो अप्रोच कर रहे थे एक दूसरे को बिफोर कोलिजन, उस रिलेटिव वेलोसिटी से ही वो क्या होंगे, सेपरेट होंगे, ठीक है, ये इलास्टिक कोलिजन में होगा. अच्छा, अब व्हाट विल बी द फाइनल वेलोसिटीज, अगर हमें फाइनल वेलोसिटीज v1 और v2 को कंसीडर करना है, फाइंड आउट करना है इन द टर्म्स ऑफ मास एंड इनिशियल वेलोसिटी, तो सी हाउ वी कैन कैलकुलेट इट. चलो बच्चों, वी आर गोइंग टू कैलकुलेट दिस. सी v2 minus v1 is equal to u1 minus u2. v1 I have taken left hand side, so what happened, v2 is equal to v1 u1 minus u2 plus v1 I have taken left hand side, u1 minus u2 plus v1. Put this in equation 1, putting in equation 1, इक्वेशन 1 में पुट करते हैं, क्या होगा बेटा, m1 u1 minus v1 is equal to m2, in place of v2 what you have to write, u1 minus u2 plus v1, here you will write u1 minus u2 plus v1, and minus u2 is here, minus u2 I also have to write. Solve this and find v1 in the terms of m1 u1 and m2 u2. We are going to solve. See here, m1 u1 minus m1 v1, here m2 u1 u2 u2 minus u2, so that should becomes 2u2 and m2 multiplied to 2m2 u2 and m2 v1. See, if you want to calculate v1 you will take one hand side, transfer others in other side. So this we have transferred left, this also transferred left, this I have transferred right. So what happened, m1 u1, this I have taken left, minus m2 u1, this I have taken left, plus 2m2 u2, this I have taken right, m2 v1 plus m1 v1. See what we have done, we have to find v1, the v1 we have taken one side and others are we have taken other side. So see here, and u1 you have taken common, so remaining is m1 minus m2. Here v1 I have taken common, that is m2 plus m1. So what will be the v1? This I have taken left hand side. So this m1 minus m2 u1 2 m2 u2 divided by m2 plus m. This is the velocity. Velocity v1 in terms of mass and initial velocity before collision. So v1 is equal to what? m1 minus m2 bracket u1 plus 2m2 u2 divided by m2 plus m1. So this is the expression of velocity in terms of mass and initial velocities. So v1 we have found it. If v1 we will put in this equation, so you can also calculate v2. So see here we are going to calculate v2. So what happened? Put this v1 in the equation first. See here we are putting in this. What happened? v1 here putting v2 is equal to u1 minus u2 plus v1 u1 minus u2, v1 is what? m1 minus m2 u1 plus 2 m2 u2 upon m1 plus m2. See, I have taken LCM. So this will multiply here. Then we will take LCM here. So m1 plus m2. To multiply one by one. Firstly m1 we are multiplying both. m1 will multiply to m1 u1 minus m1 u2. m2 will multiply m2 u1 minus m2 u2. And these are, we will write here m1 u1 minus m2 u1 plus 2 m2 u2. Simplify. If you are simplifying here, so you can see here m1 u1 and m1 u1, this two, they will add 2 m1 u1 minus m1 u2. So see, some are cancelling, m2 u1 plus m2 u1, this is minus, and this 2 m2 u2 minus m2 u2, this and this 2 m2 u2, this will minus, what happened? This comes m2 u2. So this all have gone, only one remaining, this is minus m1 u2. Simplify this. So v2 is what? u2 I have taken common. I have writing here. So u2 we have taken common. So remaining is what? m2 minus m1. m1 and this 2 m1 u1 upon m1 plus m2. So this is it. This is v1 and this is v2. v2 is equal to what? u2 m2 minus m1 2 m1 u1 upon m1 plus m2. So see here what we have seen. Velocity after collision in terms of m1 and u1. So see in these two formulas you can see m1 is replaced by m2. m1 के स्थान पर m2, m2 के स्थान पर m1, u1 के स्थान पर u2 and u2 के स्थान पर u1. तो एक फार्मूला अगर याद है, if we have remembered one formula, then another what happen, change it. m1 को m2 से इंटरचेंज कर लो, u1 को u2 से इंटरचेंज कर लो, तो you can find the another one. तो what we have abstract of this conclusion क्या निकला? इलास्टिक कोलिजन इन वन डायमेंशन, ये कंक्लूजन पहले था कि रिलेटिव स्पीड ऑफ अप्रोचिंग इज इक्वल टू रिलेटिव वेलोसिटी ऑफ सेपरेशन, मीन u1 माइनस u2 इज इक्वल टू v2 माइनस v1। सेकेंड मैंने वेलोसिटी फाइंड आउट किया। वेलोसिटी का फार्मूला कैसे लिखोगे बेटा, अगर v1 फाइंड आउट करना तो u1 लिखो और डिफरेंस m1 माइनस m2 एंड ट्वाइस ऑफ मोमेंटम ऑफ अनदर अपॉन टोटल मास। वैसे इसका भी अगर v2 लिया तो उसकी इनिशियल स्पीड u2 लो, m2 माइनस m1 डिफरेंस ऑफ मासेस प्लस ट्वाइस ऑफ क्या, मोमेंटम ऑफ फर्स्ट डिवाइडेड बाय टोटल मास। So this will be the expression of velocities। ठीक है, अच्छा एक चीज और भी है, we can use some cases here। हम लोग कुछ केसेस की बात कर सकते हैं। सपोज वन केस आई हैव टेकन कि मास आर, if two masses colliding body are equal, दोनों masses equal हो तब क्या होगा, two masses are equal, identical mass, identical objects are colliding, mean m1 is equal to m2 is equal to m, then what happen? अगर मैंने एक कंडीशन ले लिया, अगर सपोज करो ये टू masses हैं, they are in equal, तो that time what happen? If m2 is equal to m1 is equal to m, तो what is v2? अगर मैं पुट करूं बेटा यहाँ पे, या v1 ही पहले फाइंड आउट करें, तो what happen? m1 minus m2 mean m minus m, u1 2m, m2 के स्थान पे भी m लिया, u2 अपॉन m प्लस m। अगर यहाँ हम सिंप्लीफाई करें तो m माइनस m 0, 2m u2 अपॉन m प्लस m 2m, तो 2m 2m कैंसिल, दिस इज u2। तो v1 we have finded u2। What about v1? अगर हम v1 की बात करें बच्चों, अरे सॉरी v2 की, तो v2 is equal to what? Same m2 minus m1 mean m minus m plus 2m u1 divided by m plus m। Here m minus m that is 0, here 2m u1 divided by m plus m 2m, 2m cancel out, what result has come, v2 is equal to कितना आया बेटा, u1। तो ध्यान से देखें, if two masses are equal, दोनों masses अगर सेम हैं तो रिजल्ट क्या आता है बेटा, v1 is equal to u2। v1 mean velocity of object b या पार्टिकल b is equal to किसके हो गया बेटा, इनिशियल वेलोसिटी बिफोर कोलिजन जो वेलोसिटी है किसकी, b की, यानी a की वेलोसिटी b को मिलती है और b की वेलोसिटी मीन दे आर एक्सचेंजिंग देयर वेलोसिटीज। अगर दोनों मास इक्वल है, इलास्टिक कोलिजन, हेड ऑन कोलिजन, तो व्हाट हैपन, रिजल्ट क्या है बेटा, देयर वेलोसिटीज आर एक्सचेंज, मीन a की जो वेलोसिटी है वो क्या हो जाएगी बेटा, b की, और b की वेलोसिटी किसकी हो जाएगी बेटा, a की। देखो v1 है वेलोसिटी ऑफ a आफ्टर कोलिजन इज इक्वल टू क्या हो गया बेटा, वेलोसिटी ऑफ b बिफोर कोलिजन। यहाँ वेलोसिटी ऑफ b आफ्टर कोलिजन is equal to velocity of a before collision। So this I have taken one case। Case second, we have taken m1 is a smaller mass and m2 is equal to m, a very greater mass। For example, suppose a small ball colliding with wall, this is like wall, so m is much greater than m1, or you can say m1 is negligible in comparison to capital M। In that case what happen, m1 is negligible, m1 is negligible, like wall। m2 I have taken as wall, so mass of wall is much greater than a small m1, and also like wall m2 greater mass, m2 is equal to, that is a greater mass like wall। At that time what happened? And stationary. M2 is stationary. Okay. Like that we have taken. One wall is there and a small, this mass is M, and a small mass M1 with velocity U1 is striking with wall. That time what happened? To see, U1 is equal to U, U2 is equal to 0, M1 is equal to M1, M2 is equal to capital M greater mass. What will be the velocity? V1. V1 is equal to what? M1 minus capital M. U1 plus 2 M2 U2 is 0 divided by M plus M. So see here what I have told you. Okay. When we have taken a greater mass and that time M1 is very much smaller than M, so M1 minus M nearly equal to minus M. M1 is negligible. Same way M1 plus M nearly equal to capital M, because M1 is negligible comparison to M. So what happened? If we'll see here, M1 minus M, you can write minus M, U1 plus 0 upon M, MM cancel out, this is minus U. Mean that mass or that ball will rebound. Final velocity is minus Un, mean it will rebound with the same speed. And V2, you can see V2 is equal to what? If you are putting here, so M2 mean M minus M1 U2 is 0 plus 2. If you will see the velocity of V2, this wall is stationary, velocity of V2 is almost negligible, that is 0. Here 2M U1 upon M plus M. Here this is 0. You can see 2M1 upon capital M. This is almost negligible and nearby 0 because M has very much greater than M1. तो यहाँ पर हम देख सकते हैं कि अगर कोई this case also we can apply for collision of gaseous molecule from the wall, because the mass of gaseous molecule is very much smaller than mass of container. So here there you can say M1 is negligible than M2. M2 we have taken here capital M. So you have seen when they are colliding, they will bounce back with the same speed. Here I have shown you V1, velocity of M1, V1 after collision becomes U1, and velocity of V2 almost negligible 0. It's the same thing if you have taken for in case third. M1 I have taken greater mass. M1 is very big mass, greater mass. M2 is much smaller. In that case what happened? इस बार हमने क्या किया? M1 is greater mass लिया, M2 is much smaller, ठीक है, and is stationary. U2 I have taken 0. In that case what happened? Same thing if you are applying here, what happened? If you will see V1, so V1 is what? M1 minus M2 U1 plus this U2 is 0 divided by M1 plus M2. See here, M1 is much greater than M2. In that sense what happened? M1 minus M2, nearby you can write M1, and M1 plus M2 also we can write as M1. If you are writing here, this is M1 U1 divided by what? This is M1. So this will come nearly kiske U1. So you can see here V1 is equal to U1, mean the first object m1 has same speed, उसकी स्पीड क्या रहेगी बेटा, सेम वही रहेगी जो पहले थी, v1 is equal to क्या होगा बेटा, u1. But when we will talk about the v2, velocity of other object v2, if you are putting in this formula, what happen, m2 minus m1, m2 minus m1 u2 is 0 because second mass is stationary, plus 2 m1 u1 divided by m2 plus m1. Here m1 minus m2 is m1, but here 0, this is 0 plus 2 m1 u1 and m2 plus m1, this is also m1, so m1 cancel out, this is 2 u1. Main जो smaller mass has velocity 2 u1, mean smaller ball has twice of velocity of first ball. See, I have taken two stages, two cases. In one case, first mass मैंने क्या लिया बेटा, very smaller, and second mass is much greater. एक एग्जाम्पल हमने ले लिया बेटा, collision gaseous molecule and ball. So what we have seen after collision and second ball we have taken stationary. ठीक है, u2 is equal to 0. तो हमने क्या देखा, for example this wall is here, तो it will when v1 come minus u1, mean after collision its velocity becomes u1, minus u1 mean direction will change with same speed, mean the gaseous molecule will bounce back with the same speed. ये पहली कंडीशन हो गई. दूसरी कंडीशन में फर्स्ट मास we have taken greater mass, very much greater, and second mass we have taken very smaller, mean m1 here, m2 is negligible in the comparison of m1 and m2 is stationary. यानी बहुत बड़ा मास है, ठीक है, जैसे अर्थ है, अर्थ किससे टकरा गया, एक स्मॉल बॉल से, ठीक है, बहुत बड़ा मास एक छोटे बॉल से, ठीक है, एक डायनासोर ले लिया, वो क्या हुआ, वेरी स्मॉल इंसेक्ट सपोज करो, किसी स्मॉलर इंसेक्ट से उससे टकरा गया, ठीक है, अभी यहाँ मास ऑफ डायनासोर मच ग्रेटर देन मास ऑफ इंसेक्ट, ठीक है. एट दैट केसेस व्हाट वी हैव सीन, इफ इलास्टिक कोलिजन इज देयर, तो सेकंड मास हैज, जो सेकंड मास है उसकी वेलोसिटी क्या रहेगी बेटा, फर्स्ट मास की वेलोसिटी u1 ही रहेगी, एंड सेकंड मास, फर्स्ट मास हैज वेलोसिटी u1, जो फर्स्ट मास है, ठीक है, जो ग्रेटर मास है इन डायनासोर है उसकी वेलोसिटी क्या रहेगी बेटा, u1 ही रहेगी, और सेकंड जो होगा स्मॉलर मास ही विल गेट ट्वाइस ऑफ फर्स्ट मास, यानी उसकी जो वेलोसिटी है वो 0 से क्या हो जाएगी बेटा, ट्वाइस, यानी 2u1. इसको आप ऐसे भी कह सकते हो कि अगर सपोज करो एक डायनासोर है और एक स्मॉल इंसेक्ट है, डायनासोर की इनिशियल वेलोसिटी u है या 5 मीटर पर सेकेंड या 10 मीटर पर सेकेंड है, व्हेन ही विल कोलाइड विद इंसेक्ट एंड इलास्टिक कोलिजन विल बी देयर, तो डायनासोर की वेलोसिटी तो उतनी ही रहेगी 10 मीटर पर सेकेंड, बट इंसेक्ट गेट्स वेलोसिटी ट्वाइस ऑफ डायनासोर, मीन ट्वाइस ऑफ 10, दैट इज 20 मीटर पर सेकेंड, यानी v2 इज इक्वल टू ट्वाइस ऑफ u1. तो आई हैव टेकन टू डिफरेंट केसेस, ठीक है. एक केस में मैंने फर्स्ट मास जो है वो क्या लिया था बेटा, ग्रेटर मास, sorry, first is smaller and second one greater, and second case में first one is greater and second one is smaller. In both cases by the formula what will be the effect of elastic collision we have seen here.